Hey class, today we're going to start a new chapter. It is chapter 2, Properties of Matter. Now this is going to be a little bit different than chapter 1. Chapter 1 covered the general idea of science, how it's divided into different subcategories, and things that are related to science such as taking measurements and being able to perform the scientific method, and then lastly, being able to relate information from experiments into tables and graphs. This chapter is going to be the first chapter in our chemistry unit. Chemistry will take a majority of semester 1, and then we will move on to our physics unit. So let's go ahead and get started. Section 1 is all about classifying matter. Well, in order to classify matter, we have to define it. Matter is anything that occupies space, and I'm going to add to this definition, and has mass. For example, desk, people, concrete, all of these are physical things that take up space and has some kind of mass. Other things also count as matter that you don't see, such as air and oxygen. Both of these take up space as well. We breathe in air, it is considered matter. Our first major key question in chapter 2, section 1 is why are elements and compounds classified as pure substances? Now, elements and compounds were hit on in junior high with Mrs. Tom. I know she used Legos when she talked and related these to one another. Let's go back over and define them real quick before they're defined later in this video. First, elements are going to be things found on the periodic table. These are going to be one type of atom. Compounds, on the other hand, these are two or more elements chemically combined. So now that we've kind of went back over those two words that we've learned in junior high, let's go over why we classify them as pure substances. Well, a pure substance is matter that always has exactly the same composition. If you ever heard the word same composition, it means that it has the same makeup. It's made up of the same thing every single time. Sometimes you might hear this word be same and you might use the word fixed. For example, table salt and table sugar are two examples of pure substances. Both of these are considered compounds. Salt is always made up of sodium and chlorine together, and so it has a fixed composition. It will always be made up of one sodium and one chlorine. Sugar, on the other hand, has a formula of C12H22O11. That means that it will, no matter what, be made up the same way. There will always be 12 carbon, 22 hydrogen, and 11 oxygen. And you can see there always be twice as many hydrogen than oxygen. Now, as we previously stated in that key question, substances have two categories, elements and compounds. Before we move on to what elements and compounds are, let's give a key statement. One key thing to take away from this is that every sample of a substance is going to have the same properties because that substance is fixed and uniform. So since, let's say, iron is made up of iron every single time, I can have 18 grams of iron, which is Fe, in, let's say, one cup, and then another cup I can have 18 grams of iron. Both of these cups are going to have those same properties. Iron is going to be magnetic, it's going to look like a grayish black color, and it's going to not be that soluble in water. So they're the same properties. If I gave you two different cups of water, they're also going to have the same properties because they're both water. So let's go over each one of these elements and compounds. Let's begin with elements. What is an element? An element is a substance that cannot be broken down into simpler substances, which means it's the smallest that it's going to get until you get down to subatomic particles. An element has a fixed composition, and the reason for this is because it only contains one type of atom, and no two elements contain the same type of atom. For example, if we were talking about hydrogen, it is only made up of H atoms or hydrogen atoms. Iron are only going to be made up of iron atoms. So, examples of elements. Some elements are going to be solid at room temperature. If you think about a drink can or like a soda can, these are going to be made up of the element aluminum. Carbon is actually one of the main elements that you find in the lead of your pencil. Other elements like oxygen and nitrogen are going to be gases, and they're located in the air that we breathe. And then there are two elements that are liquids at room temperature, and these two are bromine and mercury. Now, all of these elements have something called a chemical symbol located on the periodic table. For example, aluminum is Al, carbon is just a C, oxygen is O, nitrogen is N, bromine is Br, and then mercury is Hg located on the periodic table. So I kind of gave a brief overview that elements get symbols. Well, chemists use symbols of one or two letters to represent these elements. That first letter is always capitalized, and the second one is always going to be not capitalized. In other words, it's going to be lowercase. Like we stated in the previous slide, the capital C is located for carbon, Al is represented for aluminum, and then gold. For example, it gets the symbol Au. Many of you guys might be like, Au, that doesn't make sense for gold. Why not G or GO? Well, that's because all of the symbols come from the Latin name. It comes from Latin language. Symbols allow scientists who speak different languages to communicate without any confusion. For example, nitrogen in our language is nitrogen, but in France it's called azote, it's called Stickstoff in Germany, and nitrogeno in Mexico. But all scientists use the letter N for the symbol of element nitrogen, so we don't get confused. Here are other pictures of elements. Aluminum, carbon, and gold are elements that you can see in common everyday objects such as cans, pencils, and rings. And there are also mixtures that contain iodine as an element that help prevent and treat infections. In fact, when you used to go get blood, they used to put iodine on your skin before they injected a needle because it helps sanitize your skin and disinfect it. The second thing we have to talk about is we're going to move on to compounds. To define it, a compound is a substance made up of two or more simpler substances, and it can be broken down. One thing I want you to add to this definition is that those substances are chemically combined. They are fused together. Now, a compound always contains two or more elements, and they're joined chemically in a fixed proportion. Now, what does a fixed proportion means? It means it's going to come together the same way. When you see water, H2O, there's always going to be two hydrogen and one oxygen. So it's a 2-to-1 proportion. Now, the properties of compounds can be different than the substances that make it up. A good example of this is water. I've stated already that water is H2O. It is made up of the elements hydrogen and oxygen. Now, if we were going to look at the properties of hydrogen and oxygen, we're going to notice these are both gases, but water, which is the compound that they make, is not a gas. It's a liquid. So that's one way that they're different. Another way that they're different is the element hydrogen actually helps fuel a fire, and oxygen keeps a fire going. If you think about a candle, it can't burn if you don't give it oxygen. However, water is completely different than those two elements. It doesn't burn and it doesn't help keep things burning. In fact, water helps put out fires oftentimes. Another example that the book gives you is silicon dioxide. Silicon dioxide is a compound. It is the light colored grains whenever you're looking at sand, and if it's in crystals of quartz. The properties of silicon dioxide is that it's colorless and it's transparent and it's a solid. Now, silicon dioxide is made up of two elements, silicon and oxygen. Now, oxygen is a gas. That's a lot different than the solid that we see for silicon. And silicon is going to be gray solid. Well, gray, that's different than silicon dioxide, which is colorless. So these two elements are completely different in their properties than what silicon dioxide actually is. Another example before I let you go is salt. Salt is NaCl. It is made up of sodium, and Cl stands for chlorine. Now, if you're going to describe these three things, the compound's name, salt, it is a solid, it is white, it is grainy, and it is edible. You can eat it. Sodium, on the other hand, it is a solid, so it has that in common, but it's not white. It is actually gray. And it's not grainy, it's very soft. Chlorine is different than salt because it is a gas. The color is not white or gray, the color is yellow. And it's actually poisonous. It means you cannot eat it. So I always think it's very funny that two things that you shouldn't be eating can, when you combine them, actually form something that is okay for you to eat. So that's the end of today's lesson. Let me know if you have any questions, and I hope you guys have a good day.